Bismillahirrahmanirrahim. Dear students of class first year, Assalamu alaikum. Now we have question number 6 of exercise 2.2, where part first is prove that determinant a minus b, b minus c, c minus a, b minus c, c minus a minus b, c minus a minus b, b minus a equals to 0. Now taking its left hand side. Now we have to prove this determinant equals to 0. So here we will add sum of these two rows in first by using R1 plus R2 plus R3. Means sum of these, first we will sum these two rows, then adding with row 1. So we have here, when we will add a minus b plus b minus c plus c minus a, then we will get 0, because a minus a cancel out, minus b plus b cancel out, minus c plus c cancel out. Similarly for next, when we will add sum of these two rows in first, we have b minus c plus c minus a plus b plus a minus b, plus b minus b will be cancel out, minus c plus c will be cancel out, minus a plus a will be cancel out, and we have 0. For last, again adding sum of these two rows in first, we have c minus a plus a minus b plus b minus a plus a will be cancel out, minus b plus b will be cancel out, and minus b plus b and plus c minus c will be cancel out. In your book, the last term of this determinant is not given correct. This is correct term is b minus c, not b minus a. There is b minus a is given, which is not correct. So you have to use b minus c here over here last term. Now finally we will get 0 0 0. The first row is 0, and write down next two rows as it is. Now this determinant equals to 0. Why? Because as we know that property of determinants, when any row or any column with 0 elements, means each element of any row or any column is 0, then that determinant equals to 0. Here row 1 is 0, so this determinant equals to 0, which is required right hand side. Now second part of question number 6 is prove that determinant 1 1 1 ABC a cube b cube c cube is equal to a minus b into b minus c into c minus a into a plus b plus c. Now to prove it, first taking left hand side determinant. Now here we need a minus b. We can get a minus b by subtraction of these two rows, means we will subtract row second from row 1. So writing by r1 minus r2. Now 1 minus 1 0, a minus b, a cube minus b cube, a cube minus b cube. Similarly for next b minus c, we will subtract third row from second, writing by r2 minus r3. So we have 1 minus 1 0, b minus c, b cube minus c cube, b cube minus c cube, and third row is as it is 1c cube. Now we have first column 0 0 1, second column a minus b, b minus c, c. For third column, we will use formula of a cube minus b cube, which is equal to a minus b into a square plus ab plus b square. Similarly for b cube minus c cube, using cube formula again, we have b minus c into b square plus bc plus c square, and last element c cube. Taking a minus b common from first row and taking b minus c common from second row. So we have, when we will take a minus b common from first row will become 0 as it is. For a minus b 1, and for this last term a minus b is common, so only a square plus ab plus b square will be left. Similarly, from second row we will take common b minus c. So first term is 0 as it is. For b minus c 1, and for the last only b square plus bc plus c square will be left. Now this determinant can be expanded easily by using first column, because here two terms are 0, so we will only use the third term, writing expanding along first column. Now we will expand this determinant along first column. The common terms will be written as it is. Now when we will expand along first column, first element is 0, so no need to write 0 because 0 into its cofactor becomes 0. Next is also 0, so no need to write 0 into its cofactor is 0. Last third. When we will use this third term, then we will ignore its column and row. Write down a determinant of rest 4 terms. So determinants of these 4 terms is 1 into b square plus bc plus c square is b square plus bc plus c square, minus a square plus ab plus b square into 1, which is again a square plus ab plus b square, and this minus sign apply on these 3 terms gives minus a square minus ab minus b square. Here one step is missing. You can do that step also, means first use minus sign outside, then apply inside. B square will be cancelled out with this minus b square, and now we have terms bc, write down minus ab, and c square minus a square. Taking b common, c minus a, and writing c square minus a square is using formula c minus a into c plus a. Now here you can see that c minus a can be taken as common term, so c minus a will be common, and the remaining terms are a plus c plus b, which will be written as a plus b plus c. So finally we got the result for right hand side, that is a minus b, b minus c, c minus a, and a plus b plus c, which is required right hand side. So it is proved.